Hello all together. Welcome to the Testbirds Testing 4.0 webinar on load and performance testing.
Woohoo! Thank you, Felix.
So first on our two presenters. Currently speaking, it's me, Felix Hupajans. I'm load testing specialist at Testbirds. And together with me is David Lokele. He's a senior project manager for QA services. And he will also later do a live demo of our load testing project. So what happened before? In our webinar series, we had some previous webinars, especially on the 28th of April on 2016, we had a webinar on innovative testing services along the development lifecycle, which gives an overview on how our services can be used in the lifecycle of a product development. Then on the 3rd of August 2016, we had a webinar on automated testing and how it benefits the website and app testing. And then on the 1st of December 2016, we already had a session of the load and performance testing webinar, but it was held in German, while this webinar is held in English. And on the 25th of January 2017, we had a German webinar on having dedicated testing platforms in the special example of a minus on-premise installation. And the agenda for today, we will have a short introduction about Testbirds, and then we'll have a small market overview, and then I'm going into details about the setup of a load and performance test, and then David will present the sample project of this of a particular load test that we conducted, and then we'll have some lesson learned and the contact. So our history. Testbirds was founded in 2011, so we are still a young company, a startup, and we have origins in the enterprise software testing market. And our customer satisfaction is currently rated as 9.2 out of 10. And we have this big vision that we developed in the recent years. It's the world's leading company for innovative testing services. So the idea is that we have services on quality assurance or user experience usability testing that utilize our crowd and cloud technologies. And we have testers in our crowd that are based in 193 countries. So that's actually all countries that are listed in the UN country list. And we have a broad spectrum of testers from normal users up to professional QA testers. And on the right, we have a few example customers that we have worked with in several projects. Testbirds is already an international company. We have our headquarter based in Munich, which operates in the whole DACH area, so Germany, Austria, and Switzerland. In this office, we have more than 40 employees from more than 10 nations. And we already conducted more than 1,000 projects from this area with more than 400 clients. And then we launched some additional offices, especially in the Netherlands in 2013, in Amsterdam, and it was launched in 2013, but moved to a new office in 2015, and it currently has 7 employees. Then we launched a franchise with Hungary that also has offices in Slovakia and Czech, and there are already 17 employees working. Then we have a UK office, which was also launched in 2013, and they have a new office in London since 2015 with 5 employees, and we have Sweden since 2014, where we moved to a new office just recently, and we have some partnerships with Italy and Russia. And our product portfolio is split into 2 main areas, that is the quality assurance and the user experience areas, and we additionally have some Testbirds exclusive. And the quality assurance, we have several different kinds of services from testing environments based on our Test Chameleon cloud or exploratory bug testing, but the ones that we are specifically looking at is most of all load and performance testing. and this can sometimes be combined with localization testing if testers from different locations or servers from different locations are involved in a load test. And in the usability and UX part, we also have a lot of different services. And actually, the load test can also be combined with a UX study. If, for example, you get subjective tester feedback on how the website is usable during particular load levels. So we can test the website with no load or a medium load or a high load and get usability feedback. And this load and performance testing service that we are offering can be built based on cloud and crowd load testing. So either in the cloud, we use our own server instances to generate tests, generate requests to the servers, or we have even our crowd testers that participate in this load test, either using the tools and generating automated load or giving individual feedback on the performance behavior. And this product can be applied in the product lifecycle, mainly in the testing and release phase. So the product should already be developed to a certain extent, and it's either pre or post-release. And we offer the service as a managed service currently, so with full support by our project management. And the pricing highly depends on the complexity of the project and the amount of load that is actually generated. So now I dive into a small market overview. So the need for load and performance testing is usually arising through performance issues or crashes of websites. So there are several reasons why a website could crash. For example, it could be an error in the code, it could be server problems, or even things like cyber terrorism in rare cases. But the main reasons, if it's not a technical issue caused by the developers of the service, is if it's too much load, especially due to a sudden surge of users. That can, for example, arise during the Black Friday shopping, which is usually one of the highest loads that appear on online shops, but there's also other reasons like a big publication or a shitstorm going on social media that leads to a sudden surge of users, and that can eventually break the website. And 75% of all smartphone and tablet users say that they would abandon a retailer's website or mobile app if it was too slow or prone to crashes. So if, for example, someone is searching for a product online and the online shop he selected for buying it is too slow or has loading errors, then he will simply buy it somewhere else, which is why it is a big issue if the website crashes. And there are lots of tools that can automatically test the performance and the load resistance of websites. So there are some open source tools like JMeter, which we use a lot in our load testing, but there are also others like Locust, Zang, HTTP Perf, or for example also Gatling is quite popular. And there are also commercial tools, for example HP Load Runner, which we also used in some of our tests. And there are also some others like WebLoad, Silk Performer, Rational Performance Tester, NeoLoad, Load UI, and even more. And now we are going to discuss a bit in detail how a load and performance test is actually set up. So the general setup of a load and performance test. First of all, we need to define the scope of the test. So we need to find out what is actually the goal of this test, what do we want to achieve. Then it's important to see what key performance indicators do we need to measure and what is our hypothesis on this. So for example, do we want to see how many testers, how many users can be on the website until the loading time of the page exceeds 5 seconds, for example? Or how many users can this website accept until the server crashes? Or how many connections will be erroneous if a certain amount of users is exceeded? How many servers do we actually need in the backend to support a certain amount of users? So there are very different ways how the key performance indicators can be questioned and what exactly we want to focus on the measurements. So it could be performance in the meaning of response times. It could be the server load during special numbers of users. and also theoretically other performance indicators like disk load, memory usage, and so on. Then what is the respective bottlenecks and how do we test for them? So sometimes a load test can be built based on a bad experience of someone. So let's say last Black Friday the online shop was down. Then we can look at what is known about this issue, how many users were actually active at this time, and how can we specifically test what arose there and how this issue can be fixed. And for this, we can specifically target the test to the scenario. Or how comparable is the test scenario to the real-world environment? This is especially interesting if, for example, a pre-release or a staging environment is tested. And also interesting if, for example, a website was being redeveloped and you want a comparison between the old and the new version. And for this, we also involve resources from the client. So it could be that some kind of server monitoring is active. Actually, that's more or less the usual case. And then we can try to incorporate this monitoring data into our test results and analyze how is the amount of load that we generate reflected in the server load. And based on this, we will make a very detailed test plan, which is what we will gonna develop as an automated test or as a crowd test, and which different stages of the test will be executed, like for example a very low load first, then a medium load, and then a high load. Then we will conduct a pre-test. So we have, for example, written an automated test script that will execute the different stages, and then we do a small test that actually does not conduct the full number of users that we will do in the real test, but it will test if we can, for example, generate the KPIs that we are actually looking for, and if we can also successfully, for example, read monitoring data from the backend system, and if the test script that we develop actually performs the actions that we wanted to achieve. And also this pre-test will have a very small analysis where we look if the actual things that we are testing for are also reflected in the results. Then of course there's the real test execution. Based on that we've already conducted a pre-test, it is actually not a big thing from what we as product managers are involved. Basically, we set up our infrastructure of multiple nodes that perform the load generation. And we, for example, also previously to the test invited our crowd users to participate. And then basically at the point where we start a load test, we click the button, we run the whole load as it was configured in the setup script. And then, of course, we are monitoring the test execution, and we have a look if actually if something goes wrong, if there's unexpected server crashes, or also if there could be problems in our test execution. And usually there are multiple test runs that are executed in a pattern. So we, for example, could also have a break in which a client set up more backend instances, and these additional backend instances are done in a second run of the load test compared to the previous test, which had less backend instances, for example. Or it could also be other changes, like if the servers are running on virtual machines, we could actually increase hardware resources. Or also possible is that we have one run without crowd testers and one run with. So there are many ways how the different test runs can be different. And based on all these runs, we will have a result analysis, which is mainly that we collect all the data that we gathered during the different test runs, and then we do a small first look at the results, because usually clients are very interested how the load test generally went, and then we dive into the more specific and also a bit more time-consuming analysis of all the defined KPIs, and we also look out for several while things that are unexpected or unusual in the specific load test. And this is usually based on the hypothesis that we defined before that. And then basically we have a final report of the load test that that concludes all the things that we've seen, that also contains graphs, and we usually also provide raw data to the client if required. We will also have an example of this, of a test report on the load test later in this presentation. So this is the general flow of a load and performance test. There's requirement engineering in the beginning and defining of the scope, what is actually tested. Then we have a small pre-test to look out for errors that we would otherwise have in the execution. So the pre-test is also usually a few days in advance. And then we have the actual test execution based on the test plan that was previously defined. And then a result analysis phase where also the final report is generated. So and now we will have a presentation of a sample project by David Lokele.
Yes, thanks Felix for this introduction. Now I want to show you the practical part. So remember the last slide. I will go through the workflow of load and performance test. Only with cloud, we don't have any testers at this example. Yeah, I just show you how we did it last time. First of all, I want to show you or present you what we did, what product we had. We had our own product, our Testbirds Nest. That's our Testbirds platform where all our testers are stored with profiles and all their devices, etc. Where we invite them for our tests, for our crowd tests, where all the test results were reported by the testers and so on. And for our platform, our development team developed a translation API where, because of our internationalization, nice word, we need to translate our platform. At the moment it is in English and German. So there was a API created, and before the release we wanted to test the limit of this translation API. And for this test we created some HTTP requests with parameters. So we give some parameters with normal HTTP requests. It was created in JMeter, the script, and executed by kind of our servers, so cloud testing, but also through our crowd, which I don't show it this time because we don't have any testers for this presentation, but I show you the cloud part. And our results we gathered in a JTL file because of the wide range of the data. We ran that test for 3 hours. We had to proceed it first with SQL because Excel was not fast enough. And then but in the end we did the graphs in Excel. I now I leave the presentation and show you first JMeter. JMeter is our favorite tool to perform load performance tests, where we create our scripts. When you start JMeter, it's very, very clean and nothing in. Of course, you can start with some examples. So if you start with a recording, JMeter brings examples with it. And if you create some here, you have the first elements for the script you need to fill out and arrange them. When you start with a recording, you will get here a test script recorder, which you use like a proxy server, and you combine it with a recording controller, which is recording all your actions, and then you have your first script already recorded. You can test it. Most of the times, or for the simple requests, simple functions of the website, for example, it would work very well. But sometimes you have to configure, or you have to deal with IDs or some data you have to manage, and then you use it further. JMeter is very, very simple. You have some basic buttons to open and save your files, run the script in JMeter itself. You can clean the results, etc. But the main part is not shown here in the main menu. It's on the right mouse click. You can add a lot of things. You find all the elements you can use to create your script by clicking on the right mouse button, and then you can add a lot of elements, configuration elements, all the listeners to gather results here, view result trees we use often to test our scripts first. Also on thread groups, you have all the maybe timer if you have waiting parts. So if after a login you need to wait maybe 10 or 20 seconds, you have to use a timer, a constant timer, or you want to simulate some random timings where people wait and look for it or scroll through a website. If you want to simulate that, you can use a Gaussian random timer, for example. And logic controller, if you have dependencies, you want to use if or loops or switches, while controller, if you want to really script a thing, you don't have to code it. You can also use all these elements instead and arrange them. It's really, really simple. Our part was this translation API for the last project. A translation or an API is it's not really comfortable to record it, so we built all the requests by ourselves. For that, we had the documentation of our API. This API has some different requests. You can get a list of all the already created translation identifier. The translation identifier is the part, maybe a button or a text field that should be translated, and you can export all these elements. You can post a new translation identifier. Maybe you have a new button or a new text field you want to translate later. And of course, you can do the translation work itself. So you can edit a translation identifier with maybe a new language part. Some of you maybe know Swagger UI. You have a very good documentation. It's interactive. You can see all the elements which are used by the API. Also, which part is required. You can test it, try it out, and it gives you feedback what's needed. If I put in some here random data and test it, I see in the end the request URL with all the elements, and also see maybe if I did something wrong or used the wrong parameters. Of course, authorization is not 1, 2, 3. I will get a error code in here, and we build that in our JMeter file. I can show it to you. That's this one here. Hello? Oh no, I don't want to save it. So we used 3 of these elements to test our API. It was the create thread, the get thread to get the list of already created translation identifiers, and edit one. For example, we have a new translation and want to edit this translation identifier. And we build that here in our JMeter. So the translation identifier to create it here, it's the main request. Also, you can use the default settings to take the main domain out, because you don't have to repeat it for every request you want to create, and then you can fill it with all the data. You have here the body, for example, of the create thread in the script. You see where we use the name and do some random strings in here. In the HTTP header, there's the authorization code and some other parameters, for example, the content type here, JSON, for example. This is repeated for it, or it's needed for all the requests in the script. And yeah, for the here, for example, here is an only once controller. That's a special recorder controller to coordinate this edit file. We wanted to get sure that if that thread starts, there is even one translation identifier created first. So we get it first, then we have the translation identifier ID, and then we can edit some, because we had to know for the next request the translation identifier for this thread. Yeah, if you created this, you can also try it out, try it in JMeter. For this, you need a listener. This time we used the view result tree. And if you run that here in JMeter, our script, you can see, okay, everything is running well. I stop it here. You can check your threads. You see what's happening here. You get an overview of all the times, loading times, connecting times, etc. Maybe a latency. If you are transferring data, you can see the bytes, the size of the bytes, etc. And also the full request. Can see in here, and the response data, what I get back from the server or from our translation API. And yeah, I can check if it's working well. If it's green, it's good, and our threads are working here. So I could start with the test. Yeah, at the end, that's because I quit the test run here. Yeah, I can approve my script by myself. And yeah, see how it's working. If not, I can correct it right here. When the script is created, we use our server to execute it. Therefore, we have our virtual machines called Test Chameleon. I hope you can see it very well. It's just a Ubuntu server simulated on one of our servers, and the script is already uploaded. I have configured my server. It started, it's running. Hopefully it's still reacting. Yes. And then it's very, very easy. I've installed JMeter as well on this server machine running, and I can start it with a simple command. I open JMeter. This JMeter should use my test file. It's a JMX file, and I also want to gather my results into a JTL file and give it a name at the end. When I execute it, JMeter starting using the script, and every 30 seconds I will get the status update on which is running. For this time I set the simulated users, or all the threads overall, to 15. And I see the 15s are active, 15s are started, no one is finished. Maybe I want to finish another thread first, so I would see it here. The thread is finished. Here's the next update. I see we did more than 1,000 threads within the first 3 seconds. We have average time in milliseconds about the response. So it's very fast here, but I also have a maximum number. I see it takes up to 5 seconds for a couple of threads to respond at this time. At the end here I see the errors, that's the total number. We have no errors at the moment, and an error rate 0%, of course. And I can control and have a look at the test running. If something is getting wrong and I get an error rate 80% or 100%, then I can be sure that the server is crashed, and I can send shutdown request or shutdown command, and I can stop my machine here. So here, command shutdown received, and it stops. When I stop the machine, or maybe nothing got wrong and I have my result file downloaded, my JTL file, I can open it with Excel, for example. I already did that for you. So it's already downloaded. For example, this one here, you will get all the results gathered by it. Come on. So first of all, I see the timestamp. That's the Unix timestamp when the thread started. You can see here my create new translation identifier thread started at this time. Sometimes we have to calculate these times to get it for visible for humans. That's a little bit weird here. I see response codes, if it's okay or not okay. You maybe know all the HTTP status codes, 400 for errors, 500 errors, etc. This time here, 201, server gives back this create translation identifier, or the translation identifier is created. If I need it, I have the bytes and latencies, etc., idle time. And if I have errors, I would see it here. Let me see. Oh yeah, we got some errors. That's from an old test. And I can analyze which thread it was, maybe why the error occurs here. I think it was a timeout. 60,000 milliseconds, that's a lot. And a clean number, or a clear number here, I think that's what the limit from our script. So it ran again a limit and failed here with an error. And all these stuff can I analyze within the raw data I get back from our JMeter script, the JTL file. When I've analyzed my raw data, now I switch back to the presentation. We saw the creation from Swagger UI to JMeter, running the test with, for example, a virtual machine on a server. And in Excel, of course, I can make some graphs out of all the raw data. For our translation API project, we had here the number of responses on the left side. So we started here with 50 running threads in parallel. This is like when 50 users would send new requests all the time. Of course, we had a lot of responses at this time, and we raised the limit, the users more and more and more. And you can see after 400 users in parallel sending a lot of requests, the graph is breaking down. So the response number is going down, and the error codes here is a 504 starting to rise. Yeah, so here is something going wrong. We are getting more and more errors instead of successful responses. On the right hand, it's the response time. It's also going up, more and more users sending requests. The response times is going up in milliseconds because every thread and every response took more time to get responded by the or answered by the server. This was the ramp up phase, for example, where we tried to find our limit. We thought that the limit would be 500. Yeah, it's a little bit sooner. We found out. Yeah, let's have a look at the ramp down phase, how this server is regenerating itself after, yeah, it's a little bit overloaded with our test. Here the load is going down from 500 to 400. Still a lot of 504 errors occurring, but here around between 350 and 300 parallel users, we have still successful answered requests. You can see them here. So yeah, between 300 and if we look back here 400, we think it's our level of our translation API. And of course, the response time is going down. The server reacts faster, answers faster. We are back with the 50 users where we started our test. If you want to have a full picture of response times, maybe we prefer to use the quartile box plot graphic. This type of graphic, the full range of all the response times are shown. You see the lowest number here. So this was the fastest time with 450 parallel users, where we get the answer from the server. Our request was answered. Yeah, here that's really bad. 36 seconds or more, 38 seconds to respond at a minimum. Most of them here, that's the 50% middle box. You see 50% in here is, yeah, between 50,000 milliseconds, that's 50 seconds, and 60 seconds. That was really, really bad. And the 60 second, that's the maximum number here. Yeah, that's what was our limit. So it's kind of get higher, we would say, yeah, these threads will never be answered at this time. So this is a nice graphic to get the full view of all the results, all the response times. You can do it also with error codes and other stuff you want to analyze in your testing. Yeah, our outcome from our testing, our server crashed with 450 parallel users, and the server was back with 3,000 users. The response time in general was under 10 seconds with 100 users. So 100 users in parallel are no problem. They were responded very, very fast and very, very quick. And yeah, we set our server limit to 100 parallel connections for our translation API. So to get safe, to get be safe that the translation API is working well at every time, and for us 100 parallel connections is okay because we only have, for example, in Munich 40 employees. So that's a lot. So maybe, yeah, it's enough. Yeah, then I would give it back to Felix.
So we're now following up with the lessons learned and contact information. And the summary of our 5 most important lessons learned is invest time in preparing of the load test. So it's very important to consider potential issues that arise from certain backend infrastructures. So let's say if, for example, auto-scaling is active in an Amazon EC Cloud environment, it's important to consider that also the backend instances that are actually active will grow throughout the load test. So things like this should be actually considered in advance, and it's important to also do all the requirements engineering to find out what actually happens in the backend systems at the client side, especially for more complex backends. And it's also important to focus on which actual results do we want to measure, which are the KPIs. Then the second lesson, test small first. If your load test suddenly crashes during the execution, it is more difficult to reschedule a load test to do all the setup again instead of having a small pretest in advance where you can identify this kind of issues. Also running tests and missing out, for example, on backend monitoring data would be bad. So the pretest is a good opportunity to check that everything's running. The third lesson learned, put the results in relation to reality. So the load test requests executed are, of course, in some extent different to how real users would behave. For example, a thread that does not have any wait times or thinking times in the script will execute the next request immediately after the previous request. So a normal user would, for example, never be able to fill out a complex form in less than 10 milliseconds. So depending on how the script is written and what exactly needs to be tested, for example, the number of load test users might not actually be the number of real users that could use the site, as real users would probably execute less requests, or this thinking time is also already included in the test script. Then the fourth lesson, evaluate the performance of your critical infrastructure regularly. So it's very important that during development of the backend infrastructure and with changes to the application itself, there might be changes in the performance behavior, and it's always better to investigate these issues regularly beforehand instead of being surprised by a Black Friday crash. And the fifth lesson learned is take next steps after evaluating the results. So after you conducted the load test, there are also some recommendations what actually could be looked out for. So maybe there was some special request that was particularly less performant than others, or it was seen that having more backend servers actually does or does not help as expected. Then the setup of the backend infrastructure can be fine-tuned, or things like connection limits can be established to ensure that at least those connections matching the limit are properly served and errors are avoided. Then what happened next? So, or what will happen next? We will have more upcoming webinars and seminars. So there's one on running your own crowd tests and introduction to Testbirds self-service. The date and time will be announced in the future. And of course, we always have current information on our website, testbirds.com. And yeah, thank you very much for joining this webinar. Below here are the contact informations of my colleague David, who did the live demo, and me. So, do you have any questions? Maybe also questions could be entered in the chat.
No, I have no questions. That was great. Thank you very much.
Thank you. We will actually keep available for a few minutes to see if questions arise. Okay, so as far as we can see, no one has questions yet.
Well, maybe I do have a question. In terms of preparation, how long would you usually need preparation time for setting up, let's say, a load and performance test for an e-commerce site which want to be ready for Christmas?
Like from now till Christmas, that would of course be a very long time, but let's say shortly before Christmas it arises, then of course it also always depends a bit on the workload of our project managers. But usually we would start the preparation at least a week before the pre-test to make the actual requirements engineering and to ensure that we test what actually needs to be tested. And then the pre-test, actually it's enough if this happens a day or 2 days before the actual load test. And let's say the test runs are all conducted on a single day, then it should be possible to do the analysis in the following week, which gives a total time frame of at least 2 weeks, or depending on the complexity of the test, more than this. So if someone wanted to buy a load test shortly before Christmas, it would be highly advisable to do the contract and the sales in November, so we can actually get this project kicked off in December. Or latest starting of December, it should be kicked off.
All right, thank you. Well, since nobody else is asking, the load test example you showed was with 450 testers simultaneously until the server crashed, right?
Yes, so it was a test that was actually planning to see the limits of the server that we used, and we were going till 500 in total, although the service was not able to handle the full 500 users. And it should be said that this server was also with very low resources, so it was 512 megabytes of RAM and one virtual CPU in a virtual machine. So as we didn't expect the service to have to handle a high load, it was more an analysis of how many resources do we need for the service with our planned capacity of, let's say, 50 to 200 users, and we found out that 100 could already be handled by this small server, which is sufficient for us.
All right. That explains also my second question. Okay, thank you.
So we have one more question from the audience. It's if I have a site in SharePoint, if there is a specific tool to test. So do you have any idea of a specific tool that could be used, David?
For SharePoint?
Yeah.
I think with SharePoint, you want to up and download files and want to measure the up and downloading file times. You can use JMeter as well and simulate the up and downloads.
Yeah, I agree. Like JMeter would be usable. It also has connectors to different protocols than plain HTTP. Also WebDAV or FTP or others could be tested. But I'm not aware of a very specific tool specifically for SharePoint. Does this answer your question? Okay, thank you for the question. Any more questions? Okay, I think no more questions. Then we'll close the session now. Have a nice evening. Bye.
Thank you. Bye-bye.
Wait, one more thing. The next session will be announced on our website. It is currently not set on which date it will happen, but we also sent around our newsletter. So if you register for the newsletter, you will get information on the next session. Okay, bye-bye.